Okay, so let's dive in. We've got a stack of sources here, articles, some recent research, our own notes too, all pointing towards something pretty fascinating.
Yeah,
Something that seems to be, well, fundamentally changing how we think about building AI, especially for businesses.
that's right. Today, we're taking a deep dive into mixture of experts models, MoE, you'll hear it called.
MoE.
And it's a really significant shift away from, those huge monolithic AI systems we've heard so much
A
about.
giant brain approach.
Exactly. And this MoE idea, it's opening up completely new possibilities, especially for enterprise applications.
Okay, so our mission here then is to really unpack what MoE actually is, under the hood. Explore why it's being talked about as such a game changer compared to the traditional models.
Yeah,
And crucially, look at how companies are taking these ideas, these principles, and actually putting them to work, in the real world, in enterprise settings.
definitely. Really wonderful analogy to kind of capture the core idea.
Oh, yeah.
Imagine an orchestra, but instead of every musician playing every single note,
Which would be chaos.
right, instead you've got this brilliant conductor who selects only the specific master musicians needed for each part of the score.
Oh, okay.
So only the relevant experts play.
Yep.
But the result, it's this perfectly harmonious, complex symphony.
So it's all about efficiency and
Yeah.
precision, using just what you need, exactly when you need it.
That's the heart of MoE. Spot on.
That's the core idea.
Exactly. And as we'll get into, this isn't just some academic exercise anymore. For businesses, this approach is actually a pretty powerful strategic shift
How so?
in how AI can be built, how it can be scaled, managed effectively.
Mm.
It changes the game.
Okay, I'm intrigued. So let's set aside the traditional big box AI model for a moment.
Yeah.
What is a mixture of experts model? Like fundamentally, how does it work?
Well, at its core, it's really moving beyond that one-size-fits-all architecture.
Right.
Instead of having one gigantic neural network trying to handle every single task thrown at it.
Which seems inefficient on the face of it.
It can be. MoE models distribute the workload. They spread it out among multiple, smaller, highly specialized submodels, and these are the experts.
Got it. So like having a team of specialists, rather than one GP trying to do brain surgery and set a broken leg.
Precisely.
Yeah.
That's a great way to put it.
Yeah.
And to make this whole thing work efficiently, you need a few key components.
Okay.
First, there's the routing mechanism. You might see it called a gate or maybe a router in the papers.
The gatekeeper.
Sort of, yeah. Its job is to look at the incoming input, maybe it's customer email or a piece of financial data, and it intelligently figures out which of those specialized experts are the best fit for that specific task.
So it's like a smart traffic controller, directing the request to the right specialist AI down the hall.
That's a good analogy. And this leads right into the second critical piece, sparse activation.
There's activation. Okay.
This is really, really key to the MoE advantage.
Yeah.
Because that router, that gate, has identified the relevant experts. Only that specific subset of experts gets activated to process the input. The vast majority of the model's parameters, they just stay inactive, dormant.
Ah, okay. That's where the efficiency boost comes from. You're not switching on the entire massive engine for every single tiny request.
Exactly.
Only the relevant parts kick into gear.
You conserve enormous amounts of computational power, memory, energy by only activating the necessary bits for any given task.
That makes sense.
Then those selected experts do their thing, they process the input, and their individual outputs are combined somehow to produce the final result.
Right.
It really is like calling in the right medical specialist. You need a cardiologist for a heart issue, a neurosurgeon for a brain issue.
Right.
You don't ask the general practitioner to handle everything at that expert level.
Yeah, that medical analogy, it really clicks. It feels so, well, intuitive when you think about how humans specialize.
It does.
But it's interesting. While it feels really cutting edge right now, this architecture, it actually goes back a bit. Didn't Google Research do some early work here?
They certainly did. I mean, the core concepts were definitely advanced by researchers, including folks at Google. There was a really notable paper back in 2017.
Okay.
Outrageously large neural networks. Yeah. The sparsely gated mixture of experts layer. Catchy title.
Ah, sounds ambitious.
It was. So, yeah, it's a concept that's been around, been refined, built upon for several years now, and that's led to its current, prominence.
That historical context is useful. Okay, so if this MoE approach has all this potential for efficiency, for specialization, what were the big problems with those traditional monolithic AI models? Why the need for this shift, especially from a business perspective?
Right, that's the crucial backdrop. Those traditional large models, things like the earlier GPT versions maybe, while incredibly powerful in many ways,
Yeah.
they face some pretty significant hurdles, particularly when you try to deploy them widely across a whole enterprise.
Okay. Like what?
Well, the most obvious one was just the high computational costs.
Yeah.
Because a monolithic model activates every single one of its parameters, its entire structure, for every single task.
Every time someone asks it anything.
Every single time. It just consumes massive amounts of memory, massive amounts of energy.
Which means you need incredibly expensive hardware, and the electricity bills must be huge, right? That sounds like a non-starter for a lot of companies trying to use it at scale.
Yeah, absolutely. Trying to scale those models to handle, say, millions of customer interactions or analyze vast data sets across a large organization, it just becomes prohibitively expensive really fast.
Okay, cost is one. What else?
Another major limitation was generalization challenges. Meaning a single massive model trying to be a master of everything, understanding subtle human language and doing complex financial modeling and extracting data from weird PDF formats.
Right.
It often ends up being just okay. Kind of good at many things, but maybe not truly excellent at those really specific niche tasks businesses rely on.
So a jack of all trades, but maybe master of none when it really counts.
In some critical specialized areas, yeah. For things like super accurate fraud detection or understanding very specific customer intent in a niche industry, you really need peak performance. And a general model might just fall short.
Okay.
And finally, there were just scaling bottlenecks, simply making these monolithic models bigger and bigger to try and improve their accuracy.
Which was the trend for a while.
It was. But it drastically increased their latency, the time it takes to get an answer, and ramped up the resource demands even further.
Making them kind of impractical for anything needing a quick response.
Exactly. Think real-time applications like live customer chat support, or monitoring critical IT systems where you need an instant alert. Delays there aren't just annoying.
They could be business critical, lost sales, system outages.
Precisely. So these limitations, these inherent problems in the monolithic way of doing things, they really drove the search for better alternatives, more efficient, more specialized, more scalable architectures, like a MoE.
Okay, that paints a really clear picture of the problem space. So now let's flip it. Let's talk solutions. What are the concrete benefits that these MoE models bring to the table, especially when we think about building AI agents for enterprise use?
Right. Well, the great thing is the benefits directly tackle those limitations we just talked about.
Good.
Because of that sparse activation, only using the necessary experts for the job, MoE models offer pretty remarkable speed and efficiency.
Okay.
Less compute power used translates directly into faster response times, faster inference times.
And for a business, that's huge. Faster customer support, quicker IT fixes.
Faster business processes overall.
Yeah.
And that efficiency, it hits the bottom line too. Cost savings.
Ah, the big one.
Definitely. Lower energy use, less demanding hardware requirements.
Okay.
Essentially, you're not paying for all this capacity to sit idle most of the time.
Right.
This makes deploying AI and actually scaling it across the whole company much more economically feasible.
That feels like almost a prerequisite, doesn't it? For really widespread AI adoption within a big organization, cost has to make sense.
It absolutely is. You can't break the bank. Then there's specialization.
No, I touched on that.
Yeah. By having these dedicated expert submodels for specific tasks, you can fine-tune them to achieve incredibly high accuracy in those niche areas.
So better performance on the tasks that matter most for a specific job.
Exactly. Whether it's, analyzing complex legal documents for specific clauses or predicting very particular supply chain disruptions, you can have a highly optimized expert just for that.
Ensuring the best possible AI tool is used for each specific problem, not just a generalist.
Correct. And this structure also brings significant modularity.
Meaning easier to update.
Much easier. The whole design makes it far simpler to update an existing expert, maybe improve it, or even add totally new, specialized experts as business needs change. And you can do that without retraining the entire massive model from scratch.
Okay, that sounds way more flexible, much more agile for managing AI capabilities as things evolve.
It really is. Think about how fast business needs change. This allows the AI to adapt more easily. And finally, this architecture is just inherently built for scalability.
Handling bigger workloads.
Yep. By distributing tasks across this pool of specialized experts, MoE models can handle enormous enterprise workloads, millions of requests, huge data sets, without that performance slowdown you often see in big monolithic systems.
Okay. And this isn't just theoretical, right?
Right, it's not just theory. I think it was a DeepMind study from 2022 on a model called GLAM.
GLAM.
And it found that MoE models could achieve similar performance levels to comparable monolithic models, but using significantly fewer resources.
How significant?
Sometimes needing as little as like 25% of the computational power.
Whoa. Hold on. 25%. For similar performance.
Yes.
That's not just tweaking the efficiency. That's transformative. That could unlock AI use cases that were simply too expensive or impractical before.
Exactly. It fundamentally shifts the whole equation for deploying AI across an entire enterprise.
Okay. So these principles, these benefits, speed, cost, specialization, modularity, scalability, they sound incredibly powerful on paper. How are companies actually, doing this, putting it into practice? Lowtouch.ai, as one example, leveraging these kinds of ideas.
Yeah, the lowtouch.ai example is interesting because it shows how the core principles of MoE are being translated into, well, real-world platforms for building enterprise AI agents, even if their exact internal tech is, proprietary.
Right, the underlying concepts are there.
Exactly.
Yeah.
Their approach seems to mirror MoE in several key ways.
Tell us how. What are they doing?
Okay, first, they seem to use a modular agent design, which sounds a lot like MoE's experts, right? Their platform is built around deploying these specific task-focused AI agents. They're not generalists. They get activated dynamically based on the exact workflow need. Is it a complex procurement approval, or is it a specific kind of IT password reset ticket?
Okay, so their individual agents are kind of like the specialized experts for different business functions or tasks.
That seems to be the idea. And then, crucially, they employ something they call a Model Context Protocol, MCP.
MCP. All right.
And this protocol, it acts a lot like that MoE gating or routing mechanism we talked about earlier.
The traffic controller again.
Pretty much. It intelligently looks at the incoming task, understands the context, and then routes it to the most appropriate specialized agent to handle it optimally.
Makes sense. It's context-aware routing, making sure the right expert agent gets the right job based on the specifics of the request, not just sending everything everywhere.
Exactly. And this naturally leads back to that core benefit we saw with MoE, adaptive efficiency.
Right.
Because the agents focus their computational resources only on the task they're assigned, it mirrors MoE's sparse activation.
So you get faster processing, lower running costs?
Compared to running one huge model all the time, yes.
Right.
The efficiency isn't just in the abstract model design. It seems built into the platform's practical operation.
So it's designed for real-world business application from the ground up.
Yeah, it appears to be the goal. And this whole approach, modular, context-aware, it inherently enables scalable automation.
How so?
Well, enterprises can then roll out AI initiatives across lots of different departments, lots of complex workflows, without immediately hitting those scaling walls, those bottlenecks we discussed. They can maintain speed and accuracy as they scale up.
Okay.
This kind of approach aims to make AI not just smart, but genuinely practical, cost-effective, and adaptable enough for diverse business needs.
Yeah, that feels like a much more, pragmatic way to tackle enterprise AI compared to just trying to build one giant super brain to rule everything.
Right. It's more engineered for the complexity of real business.
Can we look at some specific examples? Did this give illustrations of this kind of thing in action?
Absolutely. Yeah. They provided some great examples. Take IT support automation.
Okay. Classic use case.
Right. So when a user submits a help desk ticket, instead of one general AI trying to figure out everything from login issues to network failures.
Which might take a while or get it wrong.
Exactly. The system, using that routing mechanism, can figure out, okay, this sounds like a network connectivity issue. And it activates an agent specifically trained and specialized in network diagnostics.
Oh.
Or if the ticket says cannot launch application X, it routes it to a software troubleshooting expert. Maybe another for hardware problems.
So the system identifies the type of IT problem and sends it straight to the AI specialist best equipped for that specific problem. Faster, more accurate resolution, presumably.
That's the goal. Much faster, much more accurate.
Yeah.
Another example was financial reporting.
Okay, complex stuff.
Very. Generating, say, a detailed compliance report often involves multiple distinct steps. So an agent coordinating this could dynamically call on different experts. One expert might specialize in extracting specific data points from tricky PDF bank statements.
Right.
Another expert's job might be validating those numbers against the latest, constantly changing regulatory rules.
Which is a job in itself.
Absolutely. And then maybe a third expert is optimized for formatting the final output exactly according to compliance standards.
So you're breaking down a complex, multi-stage process into these discrete, specialized tasks, and each part gets handled by the optimal AI component for that part.
Precisely. Orchestrating specialist.
Yeah.
And they mentioned healthcare workflow optimization, too.
How would it apply there?
Well, think about something like patient scheduling. It seems simple, but it's complex. The platform might use different expert agents for different parts. One agent could analyze doctor availability across multiple clinics and time slots. Another might use historical data to predict the probability of a particular patient being a no-show based on various factors.
Oh, interesting. Proactive.
Yeah. And maybe a third agent handles sending out personalized intelligent appointment reminders or even suggesting rescheduling options automatically if a high no-show risk is detected.
So you're helping clinics run more smoothly, more efficiently by applying these specialized AI tools to different facets of a complex workflow, rather than one system trying to juggle all those different prediction and communication tasks.
Exactly. These examples, they really drive home how this modular, expert-driven approach, inspired by MoE principles, is being used to tackle really diverse, really complex enterprise challenges, and doing it in a way that's both highly effective and crucially computationally efficient.
So looking back at, well, everything we've covered, this shift towards mixture of experts models, it really does feel like a significant paradigm shift, doesn't it, in AI architecture?
It really does.
It seems to be moving us towards AI that isn't just powerful in theory, but actually more practical, more cost-effective, and definitely more adaptable for, widespread use across a whole enterprise.
Compared to the old monolithic way, absolutely.
Yeah.
It's about designing AI for the messy, real-world demands of complex organizations.
And it's clear, reading between the lines, that companies are already embracing these principles. They're building platforms, building systems designed for these scalable, adaptive AI agents.
Yeah, the momentum seems to be there. What's particularly fascinating, I think, is this underlying idea that intelligence itself might be most effective when it's, broken down.
Broken down how?
Into specialized, efficiently managed components that know how to collaborate effectively.
Absolutely. Which leads to a final thought, maybe for you listening. If AI can achieve such power and efficiency by being this collection of specialists, dynamically assembled for each specific problem, what does that fundamental idea, specialization plus collaboration, mean for how we might design other complex systems, how we solve problems in totally different fields, or even just how we interact with intelligent systems in the future?
Yeah.
Consider the potential of these highly specialized collaborative AI systems versus that long-held, maybe slightly science fiction dream of a single all-knowing generalized artificial intelligence.
It definitely raises some deep questions, doesn't it, about the very nature of intelligence, maybe.
Yeah.
And how specialization and dynamic teamwork seem to drive both capability and efficiency, whether it's humans or AI. Something to think about.